Hello everyone, today we're going to be working on example 4-6 and this example is asking us to replace the loading system by an equivalent resultant force and moment acting at point A. So what we're going to try to do is we have to basically find the equivalent resultant force and moment that's going to be acting at point A. Our point A is right here. And then from there, we have these forces, the 150 pounds, 200 pounds, and this 100 pounds. So to start off this problem, what I'm going to first do, the first thing that I'm going to do is I'm going to take this force of 100 pounds. And as you can see, it's diagonal. So we're going to first split that up to its horizontal and vertical forces. So as you guys could see, the first thing that we're going to do is we're going to take a look at this triangle right here. We know that this side of the triangle is 3 feet long. This side of the triangle is 4 feet long. And because of that, we know that this side is going to be therefore 5 feet long. And like that, we would have our 3, 4, 5 triangle. Now that we know that, we could proceed to finding our horizontal and vertical forces of this force right here. So as you guys can see, to find the vertical force, I'm going to start off by finding the vertical force. To find the vertical force, what we're going to do is we're going to multiply the 100 pounds by 4 over 5. And then that would end up giving us 80 pounds. From there, we're going to find the horizontal force. We're going to multiply that 100 pounds by 3 over 5. And then that would give us 60 pounds. Now that we found that out, if you guys just want to know why I did that, it's because basically this force is if we would have moved this force, if we would have shifted it down, and if it would have been right here, we could have then looked at this like in the triangle. If it would have been shifted down, the force would have the length of 5 feet. Then from there, this side would be 3 feet. This side would be 4 feet long. And for the horizontal, we would be dealing with the 4 feet and the 5 feet. And then for our horizontal force, we'd be dealing with the 3 feet and the 5 feet. So now that we found the horizontal and vertical force of this 100 pounds, now what I'm going to do next is I'm going to be finding all the moments that these forces are going to be acting about point A. So as you can see, we have 1, 2, 3, and 4 forces. So we're going to find the moment that those things are acting, the moment that it's creating about that point A. So for the first one, we're going to start off with 150 pounds right here. So I'm going to start off by drawing what is as known as point A. So we had point A here. Um, and you know what? No, I'm not going to do it. So we have 150 pounds. As you could see, or if you guys could remember, moment is equal to the force times the distance. We know our force. The only thing that's missing now is our distance. As you can see, since this is a vertical force, that means it has to align vertically with that axis of the point. So that means our distance is going to be this right here, which we know that it's 3 feet. So we know our force. We know our distance. Now we just have to figure out if that's going to be creating a positive or a negative moment. Since this is acting downwards, we know that's going to be creating a clockwise moment. And if you guys remember, for our sign convention of moments, we know that counterclockwise is positive. That means clockwise would be negative. So here we're going to have a negative moment. So let's write this out. This is the 150 pounds is going to be a negative moment. of 150 pounds, which is the force times the distance of 3 feet. And that's going to be creating a negative 450 pound feet going counterclockwise, but we want to deal with positive numbers. So that means that we have a moment of 450 pound feet acting clockwise about that point A. So that's our first moment. From there, we're going to proceed and look at our 200-pound force. As you could see, since this is a horizontal force, that just means it has to intersect that axis where that point is laying on. And as you guys could see, it's already intersecting that axis right there. So that moment, there is no moment, or it will not be affecting or creating a moment about that point. So this right here is just zero. So there's no moment for that one. Now we could proceed over at our 80 pound and 60 pounds. So for our 60 pounds, once again, it's a vertical force. So that means that it has to intersect that horizontal axis where that point is sitting on. So remember, moment is equal to our force times our distance. So our distance is going to be this 4 feet right there, because that's how much it takes for it to lie on that axis. And now we just have to figure out if it's going to be creating a positive or a negative moment. Since it's going to the right, we know that's going to be creating a clockwise moment as well. So let's write that out. So negative moment, since it's going clockwise, of 60 pounds, which is the force times the 4 feet, the distance, that ends up giving us a negative 240 pound feet going counterclockwise, but we want to deal with positive numbers, so 240 pound feet going clockwise. Now for our last moment, we have our 80 pounds. Since this is a vertical force, we want that to align with that vertical axis where that point is laying on. So the distance is going to be this right here. That's going to be our distance. So which is basically this 3 feet plus this 3 feet, which is 6 feet. So now we just have to figure out if it's going to be creating a negative or a positive moment. Since it's going upwards, we know that's going to be creating a positive moment, since it's going to be creating a counterclockwise moment. So that's going to be a positive moment. So we have a positive moment of our force, which is 80 pounds, times the 6 feet. So that means that we would be having a moment of 480 pound feet going counterclockwise. So that now that we have all the moments, we're just going to sum them up to find the resultant moment about point A. So we're just going to write that here. Our resultant moment about point A. Remember, sign convention, counterclockwise positive. And our resultant moment about point A is equal to, so sorry, there we go. So if you guys remember, these are the answers. These are the moments that we got, that we found. So the first one that we have is a 450 pound feet going clockwise. That one's going to be negative. We have 240 feet, 240 pound feet going clockwise, negative, and we have 480 pound feet going counterclockwise. That's going to be positive. So we're going to just add those up. So we have negative 450 pound feet minus the 240 pound feet plus the positive 480 pound feet. And if we add that up, we'd get that the resultant moment about point A is equal to negative 210 pound-feet going counterclockwise, but we want to deal with positive numbers, so the resultant moment about point A is equal to 210 pound-feet going clockwise. And like that, we were able to determine the equivalent moment acting on point A. So now, as you guys could see, this example was asking us to replace the loading system by an equivalent resultant force and that point A. So we already found the equivalent moment. The only thing that is now missing is the equivalent resultant force. So to find the equivalent resultant force, what we're going to do is we're going to sum up our X forces and our Y forces. So our sign convention for our horizontal forces is that right is positive, and so we're going to sum up all of our forces in the X direction. So we have negative 200 pounds plus 60 pounds, which, as you could see, our 200 pounds are pointing to the left, so that's negative. Our 60 pounds are pointing to the right, so that's positive. So if we add that together, we'd end up getting negative 140 pounds going to the right. So that means we have a positive 140 pounds going to the left. Now for our Y forces, we know that upwards is positive, so our forces in the Y direction equal negative 150 pounds plus 80 pounds. That gives us negative 70 pounds acting upwards, which is the same as 70 pounds acting downwards. Remember, that was our 150 pounds going downwards and our 80 pounds going upwards. So now that we've found the sum of our forces in the X direction and the sum of our forces in the Y direction, now we're going to be able to determine our resultant force. So to find the resultant force, what we're going to do first is we're going to sketch out our forces that we have here. Right? This is our x-axis, our y-axis, and as you guys could see, for our forces in the x direction, we know that we're going to be going 140 pounds to the left, so that means it's going to be going this direction, 140 pounds. And for our forces in the y direction, we have 70 pounds going downwards. So on our y-axis, we have 70 pounds going downwards. And we know that our resultant force is going to be somewhere around here. So if you guys remember, our resultant force is equivalent to our resultant force is equal to the square root of our two forces squared. So 70 pounds squared plus 140 pounds squared. So that means that our resultant force is equal to 156. Sorry, that is not underneath the square root. That's already outside. So 156.5 pounds. That's our resultant force. But now remember, when we deal with resultant forces, we also have to find the direction of our resultant force. So to find our direction, we're gonna be finding our angle right here. We're gonna call that theta. So our resultant force is right here. So to find that, what we're gonna do is when we find our direction, we always want to start off at our positive x-axis, and then from there we could either deal with this going clockwise, so find the angle like this angle plus this angle, and that would give you the direction, or we could find this angle going counterclockwise as well. I'm going to be finding it counterclockwise, so that means that we know that this whole quadrant, if we go completely, is 90 degrees, and these two added together would be 180. So what I would have to do is I would have to find this angle and add that to 180 to find the direction of our resultant force going counterclockwise from the positive x-axis. So to find the angle for this right here, we know that this is the angle that we're dealing with. We know the total, the force right here, the force right here. And if we were to make this into a triangle, we know that this side of the triangle is 70 pounds because we know that these two sides are the same, right? So to find this angle, we know our opposite side of that angle. We know the adjacent side of that angle. So what we're going to do is we're going to be working with tangent, since tangent is opposite over adjacent. So to find theta, we know that tangent theta is equal to opposite over adjacent. So that means that theta is equal to the tangent inverse of the opposite side over the adjacent side, which just means that theta is equal to the tangent inverse of the opposite side was the 70 pounds. The adjacent side was the 140 pounds. So that means that theta is equal to 26.6 degrees. But remember, that's not our complete answer. Remember, we said that we had to add that to the 180. So we know that we're going to call the direction or the total angle phi. So we know that phi is equal to the 26.6 degrees plus the 180 degrees. So that means that our phi is equal to 206.6 degrees going counterclockwise from the positive x-axis. And just like that, we were able to finish this example. So remember, this example was asking us to replace the loading system by an equivalent resultant force and moment. So the first thing that we did was we found the moment that was going to be acting, an equivalent moment that was going to be acting about point A, which we found that to being 210 pound-feet acting clockwise from at that point. And then from there, we proceeded to find the equivalent resultant force that was going to be acting about point A. We found that resultant force to be 156.5 pounds. And remember, when we find resultant forces, we also have to find the direction of that resultant force. And our direction was 206.6 degrees going counterclockwise from the positive x-axis. Feel free to like this video and subscribe to our channel if you guys would like to see more videos like these.